Hello. So in this video, we're going to be cutting some twin mortise and tenons with a shaper origin. Now, there are lots of ways to cut this joint, but I love exploring options and learning the characteristics of a new machine. Personally, I like gaining that experience. All right, let's get to it. Here I have some cherry boards cut roughly to size of the table saw. Then over at the joiner, I created a 90-degree corner by milling one face and one adjacent edge. And then I marked those two surfaces. Then here at my table saw, I cut the components to size, but I wasn't sure of the height of the frame or the thickness, so I left it big for now. Then it's over to the planer, and here, truthfully, I'm just showing off. I like showing my bed height lowering mechanism. Fun to use. And you should always remove backlash. You'll notice how I'm going up, and then I come into the measurement that I need. That removes any backlash out of the gears. So real quick, for those of you that don't know, backlash is that slack between parts, typically found in a gear. And so when you're moving one direction, it's tight, and then when you reverse it, there's that little bit of slack. That's referred to as backlash. So if you go past your measurement, you want to back it off and then come back into your measurement to get rid of that slack or backlash. Beautiful. All the pieces are now milled square, and they're all the same in height and width. And this is the way I wanted to configure the components. The interior will be sized for a 20 by 16, so I cut two long ones and two short pieces. Yeah, man, setting up the shaper origin, and I'm using the workstation. I love this device that you put on top. That enables quick and easy reference to the top. And here you can see I've marked all these components right on the corner because they're all going to be cut exactly the same. And basically what I'm doing here is I'm taking a 1/4-inch router bit, turning it around so just the shank protrudes, and we can set up an XY axis and create a grid. This helps to create a perfect XY reference so that the machine knows precisely where your workpiece is located. Then of course here I'm just creating what's called a scan so that the computer is reading all those markers. Yeah, this is incredible technology. This allows that machine to know exactly where it's at in 3D space to the thousandths of an inch. And this is so cool. This is where we're creating the grid, right? And so I can drop the bit down where it just slightly protrudes past the bottom of the router. And then we're going to use that 1/4-inch bit as a reference. So we'll make contact with the first part of the edge. You can see how it asks to make sure that the bit is correct size, which it is. We establish one part of that grid, and then the second part, and then we go around the corner creating this beautiful XY axis. And you can actually see that component with my little tick mark in the corner there. So you would think of the grid as graph paper, and here I'm going to modify that grid spacing, and I'll input 1/16 of an inch. And yes, of course, this will also work with metric. All right, from there we're going to go to create, and we don't need any files. We're just going to use the onboard capability. So we're going to input a rectangle basically that is 0.25 by 0.75, 1/4-inch by 3/4 of an inch, and that will be both the mortise and the tenon. How cool is that? We're going to go down about 1/8 of an inch. That's our plunge depth to start. And here, if you remember that those grid parameters, we can move this and put it into place. You can also type in the dimension that you want for that placement. Since this is a twin mortise and tenon, I'll copy that shape and move it over exactly where I want. Again, I could input that measurement, or I can just drop it in place using the grid. A lot of options with the shaper origin. You may have noticed that I allowed more than a 1/4-inch between the two tenons. That way I have a little bit of slack for that 1/4-inch bit. All right, from there we go into cut mode, and this is a little bit odd for me, but with CNC technology, you're cutting your tenon first, and then you cut the mortise, which is completely opposite of how you learn conventionally, where you create your cavity or your pocket or your mortise and you size your tenon to fit that. And the reason being is because we can make the tenon slightly oversized, knowing that we're going to be using a 1/4 inch bit. We'll have the tenon in hand and we can fit it to the pocket and make adjustments to get a perfect fit. All right, so that motion that you heard was the Z-axis establishing down to the surface. So now it knows exactly, precisely where it's at in 3D space in the X, Y, and Z axis. Fabulous, right? Now this component that we used earlier to establish a zero reference on our height, it also is a support arm, which is really important for small pieces like this. These guys have thought of everything, right? And I'm plenty far enough away from it, and since I'm following a tool path, there's no way I'm going to run into it. And boom, look at that. Yeah, man, that is awesome. And from here, it's just lather, rinse, repeat, yeah. And I believe I was going only an 1/8 inch at a time, which could typically go a lot deeper. You know, they say the diameter of the bit, so I could have gone about a 1/4 inch at a time. But my router bit was really dull, and I've since ordered some more. And for a situation like this, you would want an upcut bit because that will vacuum the pieces better. And if you saw some of my recent videos where I'm cutting veneer, that is always a downcut bit because you get less fraying on top, and that router bit helps hold the veneer in place. And I thought it'd be a lot easier just to get rid of all that excess at the table saw. And here I'm checking the depth of that shoulder cut with a scrap just to ensure that all my cuts will be, well, exact. All right, that is what we're after. Looks beautiful, a twin or double tenon. So at this stage, I have all of the components cut with tenons on all 4 pieces, right? And now we can adjust the workstation to accommodate for creating some mortises. So I decided to use a reference stop block. That way I could create mortises in 2 of the long pieces in one position and then switch out to the shorter pieces and do the same thing. And yeah, I suppose I could use double stick tape, but clamps will work as well, right? Lots of ways to do things. Okay, here we go. Same as before. So I just put in a square. This is all on board. And then for the mortise, I'm putting in the long part of that mortise first. So I input that number first, the 3/4. And again by 1/4 inch, 0.25. And then I copy it, add another one, put it into position. It's that easy. I love this machine. Then we go to cut mode and set up all those parameters. Now, if you remember when we cut the tenons, we made them a little bit oversized. And then here, initially, I was trying to make the cavity smaller than a 1/4 inch, which I was being silly. I reached out to my buddy Sean, and of course, yeah, you can't make the pocket smaller than the diameter of the bit. So with a negative offset, everything worked. And that's how we do it. We just keep on plunging deeper and deeper, a little at a time. And here we're 13/16 deep. Yeah, man. Let's see how this fits. So all this chip out here, that'll get cut off. But anyway, look at this. That's awesome. Yeah. All right, so now we can add a chamfer around all the tenons, and a chamfer on a tenon will not only help inserting the tenon into the mortise a little bit easier, it'll also prevent squeegeeing the glue off the sidewalls, right? And this came out pretty good. It's not exactly how I'd want it. You can see some gaps there, but I can fine tune that and I can make that work. All right, let's do a dry assembly here. And this is the configuration that I wanted to put the frame, just overlapping components. Kind of a different design. Yeah, I like that. All right, so the picture size is 20 inches wide by 16 tall. So I allowed 3/8, came up with 19 5/8 by 15 5/8. Dimensions check out. So now we can create a small rebate or rabbet on the back side of this frame. Here at my router table, I wanted to show you something. So I have a Porter cable router, and you can see how I doubled up the end of this wrench by just cutting one wrench and welding it to that. Because I had bought one of the offset wrenches from Porter Cable, and the first time I used it, the wrench jaw spread open. It was a piece of crap. Anyway, this works extremely well. So I decided to cut an angle on the ends of all these pieces, maybe a 10 to 15 degree, I don't remember exactly what, but I want to sand those saw marks. So an easy way to do that is to gang them all together using something straight, clamp them, and we can sand them all at once. And yes, you could use a hand plane for this. It'd be quite easy to hit all 4 of those at once, but I'm going to use a belt sander here just because I like them. So I think I'm starting with a 120 grit. Cherry burns really easy. It's notorious for burning, especially on end grain. So start with a belt that's clean, smooth, new, and rough enough to prevent that. Once you get all those saw marks out, then we can sand the scratches left by the prior grit, right? So I'm going to go from 120 to 180. And typically end grain gets sanded to a higher grit. Here I'm using 220. Now, sometimes I can't leave things alone, so I decided to cut a little bit of straight on these angled ends and then give those a final sanding. And here I'm simply marking where the stopped rabbet will end. On one component, the rabbet can run all the way through, but one of them needs to stop. So at this point, I've cut the stock down in size, I've finished the ends, and now I can create this rabbet to compensate or to allow for the picture. So you may have noticed that my first pass wasn't held tight to the fence. I'm just kind of making an initial cut to remove most of the bulk. Rabbets are notorious for chipping out, especially at the router table, so doing it in 2 passes eliminates or at least mitigates that problem. Yeah, that should work. So now that I'm done banging things around and sliding the material through the router table, I can clean up all these edges. So I went straight from the joiner and table saw, planer, and then a hand plane. My lovely lady loves Chinese food. I go there for the glue sticks. Chopsticks. Perfect for spreading glue. All right, let's glue this. I'll add a couple of magnetic protective pads, and I can clamp this and check it with a square. And you can see how acute that angle is, or maybe it was obtuse. Couldn't really tell. Anyway, I can move that clamp left or right until it clamps square. It's really important, yeah. And I simply glued and clamped 2 halves. I also thought it'd be easier to do 2 halves. That way the tenons would be going the same direction and it would just be easier to clamp. And so here I'm doing the proverbial diagonal check, which is not foolproof. Keep in mind that if this was a trapezoidal shape, those measurements would still be the same. But this did turn out square. Well, there it is out of the clamps. Strong, beautiful, flat. So now I just need to sand it a little bit, flush everything up. They're really close, and break the edges, stain and lacquer. So I decided to think ahead a little bit and come up with a solution for hanging the frame. What are you doing? So got a straight edge here. So the left side of the router can ride against that. I have some material here, same thickness as the picture frame. And I can plunge down with a little keyhole bit. And then I've put a stop there so I don't go too far. And should be pretty simple process, yeah? Let's give it a go. I'm gonna fire the camera guy. Well, I decided to use a black matte paint instead of stain, but there it is. Hope this helps somebody out there. I absolutely appreciate the views and the comments. And remember to click, like, subscribe, learn. Thanks a ton for watching.